Section 3.6, Quadratic Inequalities. Okay, so with quadratic inequalities, we're going to look at two different things, or two different main topics. The first one is graphing. And if the equation or if the inequality is given to you in two variables, more than likely you're going to be graphing. Okay, so for the steps for graphing, step number one, graph the parabola like normal. Okay, but remember your rules for solid or dashed curves. So if your inequality sign is less than or equal to or greater than or equal to, that would be a solid curve. Obviously that's a line, but it's a solid line. And then if it's strictly less than or strictly greater than, then you're going to have a dashed curve. Okay. After we get the parabola graph, go ahead, test a point on the inside of the parabola. I'll show you what that looks like here in just a second. If your tested point gave you a true statement, you're going to shade the inside of the parabola. If the test was false, then you shade the outside. And I'll show you what all that means here in just a few minutes. Okay, so let's get after it. Number one, graph the inequality. Y is greater than or equal to x squared plus 2x minus 8. What we need to do first is come up with, I would like to see a table of values. Okay, so let's do x, y. These you can get from your calculator. I'm not going to go too far as to figuring up these x's and y's. You can get them from your calculator. The vertex here is at -1, -9, and then we'll have 0, 1, -2, -3. -5 is the y value under -3, -8 is under -2, and we have that axis of symmetry and reflection. So we've got -5, -8, -9, -8, and -5 across the bottom. Okay, this is going to be a solid parabola because we have this or equal to part. Okay, so when we go ahead and graph, let me bring in some graph paper here. Let me slide that. Okay, so I'm going to have my y-axis there. My x-axis will make it right there. Okay, and we can go ahead and plot these points on the graph. So we've got -0, -8. So I got 1, 2, 3, 4, 5, 6, 7, -8. 0, -8 is right there. -1, -9 is there. -2, -8 is there, and then I need my 5. So so 8, 7, 6, 5. So -3, 5, -5 is there, which means 1, 5, or 1, -5 is there. And like I said, this is a solid curve because we have the or equal to part. Okay, so we'll draw our parabola here. Okay, so there's our parabola. There's step one. Test a point. Step two, test a point on the inside of the parabola. If we were to continue this curve, we would find that 0, 0, the origin is on the inside of the parabola. You can see that hopefully if you continue the arrows up. So we're going to test 0, 0. So we're going to plug, we're going to check, test 0, 0. We're going to put that into our inequality for x and y. So my y value is 0, greater than or equal to 0 squared plus 2 times 0 minus 8. So this is still 0. 0 squared is 0. 2 times 0 is 0, so I'm left with -8. The question is 0 greater than or equal to -8? The answer there, obviously, is yes. This is a true statement. So we got a true statement, and the point we chose was on the inside of the parabola, so our shaded area is also on the inside of the parabola. That is what your inequality looks like for number one. Let's try another one here. Number two, y is less than 2x squared minus x minus 1. Again, you can get your ordered pairs from the calculator. This section is not focused on finding ordered pairs, so I'm going to skip over that a little bit in this video because that's not the point. For reference, the vertex here is 1/4, and then I'm going to go 1/2, 1, 0, and -1. Okay. The reason I chose those values because 0 and 1/2 are the same distance away from 1/4. Same with -1. Actually, these two are not. -1 and +1 are not the same distance away. So these two numbers are not going to be the same. But again, you can get these from your calculator. Across the bottom, we're going to have 2, -1. This is -9/8, -1, and 0. Okay. Again, you can get those from your calculator. This video is not focusing on finding the ordered pairs of the parabola. So I'm just going to kind of skip over that real quick. Okay, so let's draw in our x and y plane. Let's try that one again. A little better. Okay, so we got our x and y plane. Let's go ahead and put our points on the graph. So we got -1, +2 is there. 0, -1 is there. Let's see, 1, 0 was on the graph. 1/2, -1 is about there. And then 1/4, -9/8. I mean, it's going to be very close to those 2 points. So, we have our points, not the greatest of points, but we can just try to work with it the best we can. Okay, this parabola is going to be a dashed parabola because we don't have the or equal to part. It is strictly less than, okay? So our parabola is going to look something like this. Not the greatest drawing, but just kind of go with it. 0, 0 is not on the curve. It's on the inside of the curve. That's a great point to test again. So we're going to test 0, 0. Okay, so our y value is 0, less than 2 times 0 squared minus 0 minus 1. 0 squared times 2 is still 0 minus 0, so I'm left with 1. So 0 less than -1. This one is a false statement. Okay, so we tested on the inside of the parabola and got a false statement, so we're going to shade on the outside of the parabola. Okay, so our shaded area is going to be a little bigger when we draw it. Okay, there's a couple of examples of graphing quadratic inequalities. The next topic in this section still relates to graphing, but now we're going to be graphing a system of inequalities. We're looking for where two shaded areas overlap, and we're going to be using we're going to have two parabolas on our graph. Okay, so let's go ahead and make some XY tables for both. So I'll do the first one here in red. 1, 2, 3, 4. Get me 5 points, and then we'll have -2, -1, 0, 1, and 2. I'll just underline this in red. The y values here, -1, 2, 3, 2, -1. I'll do the second one in purple. Okay, so x, y, 1, 2, 3, 4. Our x values here, -3, -2, -1, 0, and 1. It's at -1. Our y values, 0, -3, -4, -3, and 0. Okay? Again, those are just coming from the calculator. Like I said, the focus is not finding the ordered pairs, so I'm not going to spend time showing you how to get those ordered pairs. Okay, so let's go ahead and graph both of these. Let me bring in some graph paper here. Let's draw our coordinate plane. Let's try that one again. Okay, so we have our coordinate plane. Let's do the purple one first, just because it's still on the screen. We got -3, 0 is there. -2, -3 is there. -1, -4. 0, -3, and 1, 0. This one is a solid parabola because it has the or equal to part. Okay, so it's going to look like something like this. Okay, let's do the red one here. Let's see, -2, -1 is there. -1, 2 is there. 0, 3, 1, 2, and 2, -1. This one is a dashed parabola because we do not have the or equal to part. So then we'll go ahead and draw our dashed parabola. Now, my guess is that we're going to be shading where those two parabolas overlap, but we need to double check. We can test 0, 0 with both, and we'll start with the purple one. So we'll test 0, 0. Okay, so plug it in. 0 greater than or equal to 0 squared plus 2 times 0 minus 3. All that goes away. We're left with 0 greater than or equal to -3. That's true. Do the same thing with the red one. So we got 0 less than -0 squared plus 3. That all goes away. 0 less than 3. Also a true statement. So I tested 0, 0, and I got a true statement for both, which means I'm shading on the inside of both, which means that I am actually shading where those two parabolas overlap. That is your shaded area right there in between the two parabolas. All right, let's move on. I've got another example. If you want to see it in person, I can definitely show you that. But for the purpose of saving time, this is just basically the same thing as the first two examples, but now we're just doing it twice and looking for the overlap. The second main idea, so the first main idea was graphing. The second main idea is solving. And if we're solving, you're probably only going to have one variable. And you can see an example of an inequality we're looking to solve because we only have one variable. We have x. Granted, we have it twice, but it's just x. Okay, and the inequalities that we were graphing, we had x and y. Okay, so when we're solving, we're only going to have one variable. So step number one, replace the inequality with an inequality symbol with an equal symbol. Okay, and then we're just going to solve it like normal. Okay, round if necessary to 2 decimal places. We have 4 different methods to solve. We could factor, square root, graph, or quadratic formula. The quadratic formula will work every time. Sometimes factoring doesn't, square roots doesn't always work, and graphing usually works as well. But the quadratic formula would be my preferred way to solve these inequalities if it were up to me. Okay, once we get our solutions, we'll test our intervals. I will show you what that means here in just 1 second. And then once we test our intervals, we can actually write our inequalities, which are the actual solutions. So this last step, this is our solution. This is where we write our answer, okay, in that last step. All right, so let's go ahead and try this one. Number 1, solve the inequality. 2x squared plus 3x is less than or equal to 2. Now, first step was to replace the inequality sign with an equal sign. So everything else stays the same. 2x squared plus 3x equals 2. Now we need to solve it. In order to be able to solve this, we need to have it equal to 0. So 2x squared plus 3x minus 2 is equal to 0. Now we can go ahead and solve. To me, this one is probably factorable, so I'm going to try factoring here. So first step is multiply a and c. So 2 times negative 2 is negative 4. I need to find two numbers that multiply together to get negative 4 and add together to get the 3. That would be 4 and negative 1. Okay, so once I have those two numbers, I'm going to replace this number with these two. So we'll have 2x squared. I'll go plus 4x minus x minus 2 equals 0. And then, let's see, that was step 3 in the factor by grouping. Step 4, factor your pairs. So 2x squared plus 4x are both divisible by 2x. And then that leaves me with x plus 2. Because think about the distributive property. 2x times x gives me 2x squared. And 2x times 2 gives me 4x. Do the same thing with the second pair of terms. They're both negative, and I need them to be positive because remember the parentheses are going to match. So I'm going to take a negative 1 out, and that leaves me with, well, that just flips the signs. Positive x, positive 2, still equal to 0. Step number 5, write the product. So we'll have 2x minus 1 times x plus 2 is equal to 0. And then we can set them equal to 0 and solve. So 2x minus 1 equals 0, and x plus 2 is equal to 0. Okay, and then solve them both. So for the first one, we're going to add 1. So 2x is equal to 1, then divide by 2. X is equal to 1/2. Okay, so we'll keep that in mind. Second one, we need to just subtract 2. X is equal to negative 2, and we've got our two solutions. But we really haven't solved yet because we need to write inequalities. What we did is we figured out where the graph of this crosses the x-axis at 1/2 and negative 2. So we just did step number 2, solve like normal. Step number 3 now, test the intervals. Okay, so what I'm going to do, I'm going to make a number line, and I'm going to put my 2 points on the graph. Obviously, we need to put them in the correct order. Smaller number always goes to the left, so negative 2 goes out here to the left. Positive 1/2 goes to the right. Now, when I say test the intervals, we've created 3 intervals here. We've got this interval between the two numbers. We've got this interval to the right, and we have this interval to the left. Okay, we need to test those intervals, and we're going to use a number that is in each of those intervals. Okay, and we're going to test it. We could really test it in any inequality, but probably this one is going to be the easiest to use, the original one that you were given. Okay, so we got, I'm just going to write it back up here. 2x squared, let's see, plus 3x is less than or equal to 2. Okay, so let's start by choosing a number in the green interval, something to the left of negative 2, like, let's just, whoops, not text, test x equals, let's just try negative 3. I'm just choosing a number close because I don't really want to work with outrageously large numbers. Okay, so we're going to have 2 times negative 3 squared plus 3 times negative 3, and we're going to see if that is less than or equal to 2. Okay, negative 3 squared is 9, times 2 is 18. 3 times negative 3 is negative 9, less than or equal to 2. 18 minus 9 is 9, less than or equal to 2. That is a false statement. Okay, so I'm going to put an X above that interval. Go ahead and test a number in the blue interval. The number that fits in the blue interval, my favorite number to test, that would be 0. Okay, so we're going to test X equals 0. Do the same thing. 2 times 0 squared plus 3 times 0 less than or equal to 2. I'm going to slide this up. 2 times 0 squared is 0. 3 times 0 is 0, so I'm left with 0 less than or equal to 2. This is a true statement, so I'm going to put a check mark above the blue interval. The last interval, I needed something bigger than 1/2. To me, that number would be 1. Test X equals 1. We'll do the same thing. So we'll have 2 times 1 squared plus 3 times 1 less than or equal to 2. Okay, 1 squared is 1, times 2 is 2. 3 times 1 is 3, less than or equal to 2. 2 plus 3 is 5, less than or equal to 2. This is a false statement. So we have false statement in the green, true in the blue, false in the purple. So there's step 3, test your intervals. Let me go way back up. So step number 3, test the intervals. Once we've done that, now we can write our inequalities. We want to write the inequality or inequalities that tell us where the true statements lie. Where are the true statements? In this case, it is the blue interval here. Okay, so let me switch to a different color. How about we'll go to orange. Okay, so to go from negative 2, we need to go to the right. So we could say X negative 2 to go to the right, that's greater than. And since our inequality had that or equal to part, okay, our answer needs to have the or equal to part. So X is greater than or equal to 2. And from 1/2, we need to go to the left. Okay, so we'll have X less than or equal to positive 1/2. Now, just as a side note, if you have an inequality where you're looking in between two sets of numbers, like in here, okay, in between the negative 2 and the 1/2, you can write a compound inequality where you write the smaller number first, followed by less than or equal to your variable, less than or equal to the larger number. Either one of these two sets of inequalities would be correct on a quiz or test. Okay, if you want to write it like the brown one, go ahead. If you want to leave it as the orange one, also fine. Okay, but you do need 2 inequalities in your answer. Let's go ahead and try another one here. Whoops, didn't slide that up when I made the video, or the slide. Okay, so number 2, negative 3x squared plus 4x minus 4x plus 1 is less than 0. Right now we are, it's already 0, so we can go ahead, just make it equal to 0. So negative 3x squared minus 4x plus 1 equals 0. Now, let's use the quadratic formula here. We can remember we have our formula, x equals the whole negative b plus or minus square root of a lot. Let's just go through it. So x equals, my b in this case is negative 4, so we're going to have positive 4 plus or minus the square root of negative 4 squared minus, that's a squared, 4 times my a, which is negative 3, times my c, which is 1. All of that is over 2 times negative 3. Okay, so let's keep going. We got 4 plus or minus the square root of negative 4 squared is 16. Negative times positive is a positive. 4 times 3 times 1 is 12. And this is all over negative 6. Let's see, let's keep going. So we got 4 plus or minus 16 plus 12 is 28, all over negative 6. Now at this point, if you want to use your calculator, because it did say to estimate or round to 2 decimal places, let's go ahead and do that. What we're going to find is that when we do 4 plus the square root of 28 over negative 6, what we're going to get is negative 1.55. And when we do 4 minus the square root of 28 divided by negative 6, we get something that is approximately 0.22, positive 0.22. Okay, so let's go ahead and make our number line. So our smaller number goes to the left, negative 1.55. Our bigger number to the right, 0.22. We've got our 3 intervals. We had the blue one in the middle, purple one out to the right, and green one out to the left. Okay, so we have 3 intervals to test. Again, I'm going to write the original inequality again. Negative 3x squared minus 4x plus 1 is less than 0, because that's what we're going to be referencing when we do some testing. Let's start with the green one again. We need a number smaller than negative 1.55. To me, that would be negative 2. So we're going to test x equals negative 2. So if negative 3 times negative 2 squared minus 4 times negative 2 plus 1, we're going to see if that's less than 0. Let's see, negative 2 squared is 4, times negative 3 is negative 12. Negative 4 times negative 2 is positive 8, plus 1 less than 0. Negative 12 plus 8 is negative 4, plus 1 is negative 3, less than 0. That's a true statement, so we get a check mark on the green interval. The number that stands out to me in the blue interval, that would be 1. Test x equals 1. Or not 1, sorry, 0. 0. My bad, 0. So we're going to have negative 3 times 0 squared minus 4 times 0 plus 1 less than 0. Lots of zeros there. This whole thing cancels, that whole thing cancels. We're left with 1 is less than 0. That is a false statement. So we're going to put an x above the blue. And then let's test a number bigger than 0.22. Like this time we'll test 1. Test x equals 1. So we'll have negative 3 times 1 squared minus 4 times 1 plus 1 less than 0. 1 squared is 1 times negative 3 is negative 3. Negative 4 times 1 is negative 4, plus 1 less than 0. Negative 3 minus 4 is negative 7, plus 1 is negative 6, less than 0. True statement. So we have our check marks. Now this time we are going to the left of 1.55 and to the right of 0.22. So we're going to have 2 separate inequalities again. Our original inequality does not have the or equal to part, so our answers are not going to have or equal to. So we're going to have x is less than negative 1.55. And then we'll also have x is greater than 0.22. That would be your solution for example number 2. Now, example number 3, let's try one more. 2x squared plus 2 is greater than negative 5x. All right, so let's go ahead and make this equal to 0. I'm going to do 2 steps in one. So 2x squared, I'm going to bring the 5x over, plus 2 equals 0. Now, for the sake of saving time, I'm going to switch colors here. I'm going to write yellow. I'm just going to write quad form. I'm going to do the quadratic formula. I'm not going to show you all the work this time because, like I said, I'm trying to save time here. So our 2 answers when we do this, x is going to be equal to negative 2, and x is going to be equal to negative 1/2. All right, I want to go back. Actually, I'm going to make my number line here first. So negative 2, negative 1/2, smaller number always goes to the left. I want to go back to these 2 number lines. So here's number 2, we had x, check, x, and in number 1 we had, whoops, that was number 1. Number 2 actually was up here, sorry, check, x, check. You are never going to have 2 x's or 2 checks right next to each other. So if this interval here is an x, that means this one here has to be a check, which means this one has to be an x. Or the other way around. Okay, so really you only need to test one interval. Okay, you only need to test one interval because if you test one, you'll know the other 2. I'm going to choose the interval that's got 0 in it every time. This time 0 is out here in the blue. Okay, so we're going to test x equals 0. Okay, so we'll have 2 times 0 squared plus 2 is greater than negative 5 times 0. Okay, that becomes 0 on the right, so 0. 2 times 0 squared is 0, so we're left with 2 is greater than 0. And this is a true statement. Okay, so we get a true out there, which tells me I can't have a check right next to it, which means this one has to be an x, and I can't have an x right next to an x, so that's got to be a check there. Okay, so when we write our solution, this is actually going to be pretty darn easy. So I need to go to the right of negative 1/2, to the left of negative 2. My inequality sign is not going to have the or equal to part because it doesn't have it in my original inequality. So I'm going to have x is less than negative 2, and I'm going to have x is greater than negative 1/2. That would be your solution for problem number 3. All right, I've got about 5 minutes left before the app cuts me off here, so let's try to knock out a story problem. A rectangular playground must have a perimeter of 320 meters and an area of at least 5,000 square meters. Describe the possible lengths of the playground. So let's maybe draw a picture here. We know that this is the length, this is the width, this is the length, this is the width. It tells us the perimeter is 320, and the area must be at least 5,000, so that's greater than or equal to 5,000. All right, so the perimeter means the distance around. We add up all the sides. So that's going to be, we have two lengths, 2L plus two widths, okay? And that is equal to 320, so we'll keep this in mind. The area, let me switch to a different color here, we'll use blue. The area, that's length times width, and that says it has to be greater than or equal to 5,000. So we kind of have a nonlinear system here, nonlinear system of inequalities, or an equation and an inequality. And let's see if we can't knock this out. So what I'm going to do first, I'm going to solve this red equation here for W. Okay, using algebra skills, I know that 2W is equal to negative 2L plus 320. Okay, just subtracting the 2L over, and then you divide both sides by 2. So W is equal to, let's see, negative L plus 160. And what I'm going to do with that is I'm going to take this and I'm going to substitute it right there in for W. Okay, we're going to use the substitution method here. So we'll have the length times my width, which is negative L plus 160. That's got to be greater than or equal to 5,000. Okay, we'll distribute here. So L times negative L is negative L squared. L times 160 is 160 L, and then we're greater than or equal to 5,000. So really we're solving this inequality here. We need it to be equal to 0. So we'll keep working in purple here. So we'll have negative L squared plus 160 L minus 5,000 is equal to 0. Okay, we'll use our lovely quadratic formula here. Quadratic formula. And what we're going to find out is that L is equal to roughly 42.5, or L is about 117.4. Okay, we'll have our number line here. We'll bring our number line back in. We got our two numbers, 42.5 and 117.4. We need to test. 0 is down here. 0 is to the left. And our inequality, we'll just use this one here. So we'll have negative 0 squared. That's an awful 2. Negative 0 squared plus 160 times 0. And we're going to see if that is greater than or equal to 5,000. Okay, 0, gone. So we got 0 greater than or equal to 5,000. Obviously that's not true, so we'll have an X here, which means check, and then X. So the solution, the values of L that work are these numbers in here. The numbers in between 42.5 and 117.4. So the question asked, or the task, is to describe the possible lengths of the playground. Well, the lengths of the playground, length must be between 42.5 and 117.4 meters. Okay, so whatever the length is, it's between one of these two numbers, so there's lots of options. That would give us, we'd have to figure out the width to make the perimeter 320, but that would give us an area greater than 5,000. So the directions said describe the possible lengths of the playground. This would be your answer right here. The length must be between 42.5 and 117.4 meters.